Alright, hey everyone, good morning. Hope your day is going well so far. So, as I said yesterday, right, today we're going to go through the classwork, which is also the homework assignment for yesterday's lesson on partial sums of arithmetic sequences and geometric series. Okay, so here are the 4 questions that are on the classwork slash homework. I'll give you some time to work in it on your own for a bit, and then after that, I'll go through the solutions with you. So let's say 11:20, and then at 11:20 we'll um, talk about these solutions. Okay. Okay. So again, if you just came in, just work on these 4 homework questions. I know it says classwork, but the homework was to finish the classwork. Work on these 4 questions until 11:20, at which point we'll go through the solutions together. Okay, if you just came in, we're just working on these 4 questions. These are the homework questions due tonight. And yeah, we'll reconvene at 11:20 to go through the solutions. Okay, so let me pause you here. I'm going to scroll up for the solutions. And here's the one for question 1. Okay, so the first question was, an amphitheater has 50 rows of seats with 30 seats in the first row, 32 in the second, 34 in the third, and so on. Find the total number of seats. Okay, so hopefully this should remind you of an arithmetic sequence. So there's 30 seats in the first row, 32 in the second row or term, right? 34 in the third, and so on. And here, 50 rows in total, so like 50 terms in the arithmetic sequence. Okay, so in that case, n is 50. But yeah, here I write the number of seats in the rows form an arithmetic sequence with a equals 30, right? The first number is 30, and the common difference here is 2. And since there are 50 rows, the total number of seats is the sum. We're going to use this formula from yesterday, right? S sub n is equal to n over 2, parentheses 2a plus n minus 1d. So S sub 50, right, since there are 50 rows, n is 50, equals 50 divided by 2, bracket 2 times 30, plus 49, which is 50 minus 1, times the common difference of 2. And if you calculate all of that, you get 3950. So 3950 seats in this theater. Okay. So take a sec to make sure you have that down. And again, this is a homework that is due tonight, so just make sure you write this down, submit it on Google Classroom for credit. Okay, I'm going to move on to question 2. How many terms of the arithmetic sequence 579 must be added to get to 572, or to get 572? Okay, so we're going to use the same sum formula. S sub n is equal to n over 2, bracket 2a plus n minus 1d. Here in this case, right, we already know the sum that we want, which in this case is 572, and we're going to solve for n, right? How many terms are there in this arithmetic sequence to get 572? We have to solve for n. So we have n over 2, bracket 2 times 5, right? 5 is the first term, plus n minus 1 times the common difference of 2, right? 5 to 7, 7 to 9 is 2. And again, the common difference is 5. Sorry, the first term is 5. A is 5, okay? From there, you just do a little algebra. So here, at this point, I'm going to multiply it through by, so I'm going to multiply through by n over 2. So n over 2 times 2 times 5, right, the 2 divides out, so you just get 5n here. And then we have n over 2 times n minus 1 times 2. So here again, 2 divides out, you get n minus 1 times n. Simplifying further, you get 572 equals 5n plus n squared minus n. And then from there, you get n squared plus 4n, and then subtract 572. You get 0 on the left, right? And you get this quadratic equation. From there, you can factor. You're going to get n minus 22 times n plus 26. And for that, feel free to use a graphing calculator to see where the x-intercepts are, right, to solve for 0, right? But yeah, this would factor to these two terms, which would yield n equals 22 or n equals negative 26, right? But in this case, only n equals 22 makes sense, which, there should only be one answer, right, to get 572. But yeah, a number of negative terms, that wouldn't make sense. Okay. Anyhow, the answer is going to be 22 terms for your final answer. Joel?
Yeah, so we learned two formulas, right, to solve these questions. So could we use the other one?
Yeah, the other one is fine. If you want to use the other one uses n divided by 2 times a plus a sub n. And for that, you would have to solve for a sub n. right? Well, I guess, yeah, in that case it would be harder because you need to know what the last number is. Um, yeah, but to know the last number, you have to know like how many terms there are. So in this case, I would use this formula. Yeah.
Okay, thank
Well, actually, thinking about it further, what we would end up doing is, you solve for a sub n using the a plus n minus 1d formula, right? Any term in the arithmetic sequence can be found using, the first term a plus n minus 1 times d, right? And then, which is actually what you know, which is actually what we have here, right? It's just a plus n minus 1d, right? Which is, 2a plus this. So you actually end up with the same thing. Um, but yeah, like for that formula, I would just use that if you have the last term already. So you don't have to like, you know, substitute that in and then get this formula. But yeah, does anyone still need one or two? Okay, if not, then I'm gonna move on to three then. Okay, so this one is about a geometric sequence. And this one reads, find the eighth term of the geometric sequence, 5, 15, 45. Would anyone like to explain this one? I'll open up to the floor. Okay, then I can go ahead and explain it. So yeah, the first term, as we can see, is 5 in this sequence. This is a geometric sequence, so instead of a common difference, right, we're multiplying. Instead of adding, we're multiplying by some number to get to the successive terms. Okay, so in this case, right, all you have to do is take two successive terms and divide them to find the common ratio. Take the latter term, divide that by the previous term, right? So in this case, I did 45 divided by 15, which is 3. You could do the same thing with 15 and 5, so 15 divided by 5 is also 3, right? But I use this. Either way, R is 3. And then from here, we can find the eighth term, right, using this, I wouldn't even call it a formula, just, this relation between the nth term in a geometric sequence and um, the first term and the common ratio, right? So we want to find the eighth term, so I'm just going to plug in what we already know. The first term, a, is 5, so write that in there. The common ratio, as we just solved for, is 3. And then we take that to the power of n minus 1. Again, we do minus 1 because our first term, we call that a1, not a0. So yeah, we have that. From there, we plug in 8 for n, right? So a8, the eighth term, is equal to 5 times 3 to the 8 minus 1, which is 3 to the 7th. If you plug that into your calculator, you're going to get 10,935 as your final answer. Okay. Does anyone have questions on 3, or just want me to copy this? If not, then we'll go into 4. Let me zoom out for this. Okay, zoom back in. Would anyone like to explain question 4? This is the final answer, 567 over 16. Okay. All right, if not, then I'll go ahead and explain it. So here we're just going to use this relation between the nth term in a geometric sequence and the first term in the common ratio, right? So an equals a times r to the n minus 1. And here we're given the third term, which in this case is 63 over 4. And we're also given the sixth term, which is 1701 divided by 32. And our job is to find the fifth term. Okay. So yeah, from there you just plug in what we know. So a3 is equal to a times r to the 3 minus 1, which is ar squared. And then a6, the sixth term, is equal to ar to the fifth. Okay. But we know that ar squared is 63 over 4, right? That's the third term. And the sixth term is ar to the fifth, and that equals 1701 divided by 32. From here, we have two unknowns, right? We don't know what the first term is, a, and we don't know what the common ratio is, right? But here we have two equations, so we can solve for both unknowns. Okay. So to find the common ratio, I'm going to first divide the equations. So I do ar to the fifth divided by ar squared, and then at this point, I would use a calculator. You get r cubed is equal to 27 over 8. And we get r cubed because we divide that out, assuming it's not equal to 0, right? And yeah, it wouldn't be able to be 0 because in that case, 0 times any common ratio would just be 0, right? So yeah, a divides out, and then r to the fifth divided by r squared is r to the third. So you get r cubed equals 27 over 8. That's like this fraction divided by that fraction. From there, you take the cube root of both sides, you get r equals 3 over 2. So that's the common ratio, right? We multiply by 1.5 or 3 over 2 to each number. So we know what the common ratio is. R is equal to 3 over 2, but we still don't know what a is, right? We don't know what the first term is, which we need to solve in order to get the fifth term. Okay. From here, I'm going to substitute. So I'm going to use the first equation. You could also use this second equation to solve for a. But I use this because the numbers are smaller, right? So 63 over 4 is equal to ar squared. So 63 over 4 is equal to a times 3 over 2 squared. And then from there, you can solve for a, you get 7. And then from here, we get our formula for any term in this geometric sequence. So a sub n is equal to 7 times 3 over 2 to the power of n minus 1. We need to find the fifth term, so plug in 5 for n. You get 7 times 3 over 2 to the power of 5 minus 1, which is 7 times 3 over 2 to the fourth. From there, you can solve the fifth term, and that's going to be 567 over 16. All right, but yeah, while you finish copying this, let me close with announcements. Two things for today. One, there's SGI today per usual, 2:47. Secondly, a reminder that our next and last quiz is tomorrow. Please check Google Classroom for the topics list. I also updated it so that it includes the corresponding homework assignments for your convenience. Okay. Yeah. Other than that, you're free to go. And yeah, I'll see you tomorrow. Have a great day and take care.
Thank you.
All right, you're welcome. Thank you, you too.